Hello everyone, my name is Dipesh. I'm an application engineer at Adonics Technologies Private Limited. So today our topic is handling SOLIDWORKS large assemblies with ease. So what do you mean by large assemblies? So we can consider components more than 500 or more than 300, 400 in one assembly. We will consider it as large assembly. As you work on large assemblies, there are number of components, there are number of standard components that you input in an assembly, and then you realize that my system is not working properly. It gets slow. It is somewhat laggy. So these problems usually occurs. So in order to minimize, or we can say in order to optimize the working of assembly, there are some best practices that you guys have to follow that would increase the performance. Speed is increased. So we will go through each and every best practices that SolidWorks has recommended to us. So our agenda for today will be, we'll first see whenever we open a drawing or whenever we open a assembly, what all things happens, how is the hierarchy of opening and closing of a document, we'll see. Second, we'll go for best practices to improve open time, means opening time of an assembly. How can we improve opening time of an assembly? We'll see best practices to improve update time of an assembly. Again, we'll see same with drawings, and there are some hardware consideration that in order to work efficiently on SolidWorks, and then we'll have query session. So we'll directly move to our presentation. Our first part will see what all things happens when you open an assembly or a drawing. So we'll go one by one as per the diagram. You can see first you open an assembly or assembly drawing. So it loads all the reference parts and sub-assemblies. After that, it updates any part or sub-assembly that are out of date, or maybe we can say it is of a lower version. It updates it, solve all the meds and the position of the components. Next, it update in context features and assembly features. If there are any in context features or assembly features you added in your assembly, that will get updated. And then second and last thing, it paints the display and update the assembly. So during if there is any changes, in context features or assembly, it's again go and solve all the mates. So likewise it happens. Same with assembly. If you go and open assembly, in background it loads all the components, it loads all the things that happen that we discussed above, and load all the configurations of assembly which is referenced by drawing. Okay, if you have different configurations for different components, that all are updated. Show updated assembly in draft quality view, projection and named views. Next, it update views, section view which is dependent on other views. So these dependent views are updated. Then rationalize the layer and font size, line font to display final drawing. So it and at last it updates the lines and fonts and all the things. So this all process happens in background if you go and open a drawing or an assembly. So this is very important to this hierarchy is very much important to you guys to know, that you will understand that where exactly I have to work, where I have to minimize. So this was the agenda for to know this hierarchy. Next we'll move to the best practices. First we'll see how we can improve open time. In that we have our first point is to work locally. it takes longer to open and save files over network. Usually, if you are working on network, and this issue has occurred many of the organizations. So usually, what happens? There is mandatory to work on network. You have to keep all the file source, file data on network. So you have to open the file from network location only. So SolidWorks is recommending to work locally. If you have all the data set on network, you have to copy that data set. You have to work. You have to change all the files of all the changes you have to do. You have to create a drawing. All every daily basis work you have to do locally, and at the end of the day, you have to copy that back on network. So, and also we have a solution to do all this task automatically. We have SolidWorks product data management software. So all this tedious task is done automatically by PDL. Second, we have different modes in assembly. So this is very much important to understand which mode is appropriate for what kind of assemblies you are working on. So we'll see one by one what are the different modes in assembly. Okay, I will directly move to SolidWorks screen. I will open one assembly from here. So you can see there are different modes such as large design review, lightweight mode, and resolve mode. Right. So first of all I will open assembly in resolve mode. That is normal mode. We usually use this mode. So what exactly this mode is? You open each and every component with its design tree. You can see here it has all the features you have inputted in that component, and you can see it, you can edit it very easily. But this mode is very much expensive if you consider a large assembly, so you have to avoid working on this mode. There are several different modes that you can use to open assembly, work on it efficiently. So as it opens each and every data of the component, it is very much slow if you consider a large assembly. Now I have opened that assembly is not that large, you can say it is 90 to 100 components. But if you open large assembly with more components, it will take much time. It will take much time to open the assembly. Okay, so as this is normal mode, we will move to second mode. I will close this quickly and select lightweight mode. This mode name itself represents that it is lightweight. I will go and open that assembly lightweight mode. You can see it is very quickly opening. What exactly this mode is, it generally opens a solid body but not shows okay, right. So you can see that at the icon there is a feather which indicates that it is in lightweight mode. You cannot see any features you have edited in the drawing, in the component. Everything is hidden. It only opens solid body data. Okay. Now the question is, if you want to edit any part or something, so we will directly right click that component and set it as result. Do the necessary changes in that particular component, and then again right click that subassembly, and you will get to see the option set to lightweight option. So you can see again the feather is occurred on that particular component. So very easily you can work out in this lightweight mode. It is very much recommended if you are working in large assemblies. Okay, so next you have heard about large assembly mode. So what exactly that mode is? So we'll see it. I will just go and change the settings. Assembly. So this particular setting is a threshold. If you are working in assembly and your components are more than 500, if you check this option, if your components are more than 500, it will automatically consider that particular assembly as lightweight mode and large assembly mode. So I will uncheck this to in order to show what exactly the large assembly mode is. I will close this assembly. Okay, I opened first of all I opened this assembly in resolved mode. So now in assembly tab you can see the option is large assembly settings. So what exactly this large assembly settings are? So there are number of settings SolidWorks has provided in the setting tab. You can change, you can manipulate things from here. Uh, in order to optimize performance of SolidWorks, they have provided some sort of settings. What large assemblies it directly clicked or enabled all that settings which is helpful to increase the performance, which is helpful to boost your SolidWorks performance. So this is directly get activated. You don't have to do it manually. There are number of settings. You don't have to go and check all the things, and you have to don't have to remember all those things. You directly have to activate the large assembly mode, and you can see all the settings are activated, right? So working in large assembly settings is very much important if you have a number of components, if you have a number of mates involved in it, a number of standard components. So it is very much recommended to work in large assembly mode. You can go with lightweight plus large assembly mode. Large assembly will activate all the settings, and lightweight will do its work by hiding all the feature data, so which is helpful to increase your opening time of SolidWorks. Okay, and last mode we have is large design review. We called it as LDR mode. LDR mode was lately introduced in SolidWorks 2012 or something. In 2018, 2019 and 2020, there are number of improvements, there are number of new features added in large design review mode. So what we'll see, I will just select here large design review mode. I will edit, and you have to check this edit option. If you are not checking it, it will only go into view mode. You can only view the assembly. If you want to do some changes in, if you want to work in large design review mode, you have to check this option, and I will open it. So you can see very easily it gets open. Within a fraction of second, your assembly is open. You can see all the components, and there are some things you can do in large design review mode. You can see in this icon there is a I which indicates review. Basically, it doesn't show any feature data. Basically you can open or you can start building your assembly in large design review mode. If you know that there are a lot of components you have to make in particular assembly, you can directly go to large design review mode and you start inserting. You can insert the components. Earlier it was not, this ability was not there with SolidWorks to insert components, or you made the components in large design review mode, but since 2019 it has introduced, you can also do linear component pattern or circular pattern, which are most useful thing if you are working in assembly. Okay, this so large design review is basically you can't edit a component, if you have all the components ready, you have to only make the components. You can open this assembly, or it is very much easier to review your assembly. If you want to show your assembly to your boss or something, you can directly open the assembly in large agent review mode, and you can show it. You can also do section views. Okay. So basically it is efficient, but it doesn't it doesn't enables you to edit in each any component, or if you want to do in context things, there are some features they have enabled here, like linear component pattern or circular pattern. Okay, so these are all the modes that you have to work. I recommend you to work in lightweight and large assembly setting mode. It is very much easier, and you can edit your components. You can add in context features to it by easily right clicking and set your component to result. From here itself you can set your assembly into result mode or lightweight mode. Yes, this concludes the different modes in assembly. So I expect that you guys have understood all the modes. I've seen all the modes in assembly. Next, it is recommended to use simplified version of a model. Okay, what exactly is it? So simplified version, I will show you an example here. Actually, close it up. So you have this fastener here. I know everyone has a SOLIDWORKS toolbox, so to use the fasteners. But if there is any special requirement or something, you have to import it from third-party websites, or you have to create it manually. So these fasteners, you can see, I have created two configurations. One is default one, which contains thread or something, thread and all the features you can see. But it is not necessary to input this fastener to a large top level assembly, because what happens, uh, this particular thread, if you are adding we can say 100 or 200 fasteners in your assembly, calculating all this thread area, it contains lot of graphics in that particular assembly, and it again it leads to low performance or assembly. So it is recommended to use simplified model. So I have created an configuration of simplified where I have suppressed all this thread area, which is not necessary, and I can I can input this fastener to your top layer assembly. So again, if you have any sub assembly, if you want to show it in top level assembly, you can very easily use simplified model of that sub-assembly, and you can input into top level assembly. And if you are creating a drawing of that particular sub-assembly, you can easily toggle to default mode to show all the details. Okay, so this is very much important to bring under consideration, that if you are using all such fasteners, you are using some standard components such as motor, such as you can say cylinder, pneumatic hydraulic cylinders, different gearboxes. You can use the simplified version to input in drawing. You don't have to give manufacturing drawing or something to anyone, because they are standard. You have to there are brought out items. You can use simplified model to just to show in your top level assembly, which may contribute to increase your performance. Okay, so this our next point is convert data forwarded to latest version. Okay, so if you created assembly in let's say in 2016, so it was 2016, you have some components saved in 2016. So you are working on 2019 version. It is very much necessary to convert all your components in an assembly to a latest version. So this also a one point that you can consider, right? All the components should be in latest version you are using. Okay. To see assembly open progress indicator to check the status of operation while you open an assembly. So it basically shows you what all things are happening while opening an assembly. You can track it, and you can wait until all the processes are done, and then you can start working on assembly. It is a simple thing, but you have to bring under consideration while working. Okay. So these are all best practices we see which will help you to increase opening time. Now and see what all are the best practices to improve update time. So basically, what do you mean by update time? So you have open and large assembly. Okay, you know that you came to know that you have to do some last minute changes, or you have to add or remove a component. You have to add some features in that component. Okay, so while doing that, you have faced lot of issues, such as it take very much, it takes time to get update. Sometimes while doing that, SolidWorks get crash. Okay, SolidWorks crashing is most, we can say, common issue which are faced by design engineers in every industry, every company, we can say. So how exactly we can improve the update time, we'll see. There are some points SolidWorks are recommended to use, take into consideration while working in large assemblies, or if you want to improve update time. So first, you can see the limit in context features. Okay, so what exactly? If you are using any in context features, such as there are many assembly features that you are using, so try to minimize those in context features. Such as you are using assembly features, you are using whole wizards on assemblies, directly in assembly mode you are introducing holes or something. Okay, so try to minimize it. I know there are some mandatory requirements that you have to take references of different components, and you have to input a hole or something. So that time it is considered, but try to avoid that in context features. Okay. Second thing, it is limit mates by using rigid sub-assemblies. So what happens? You have sub-assembly, so it is flexible, so it is moving. Each and every, if you had made those components to get a motion or something, it is moving. So sometimes it is requirement of having flexible sub-assembly. Sometimes it is okay to use rigid subassembly. So try to use rigid subassemblies to improve. Subassembly has different mates. Okay, top level assembly has different mates. If you are using rigid subassembly, those mates are not, those are untouched. You can directly made that subassembly by using three mates in top level assembly. You don't have to take care of mates of subassembly, and so it will help to increase update time. Because if you are having flexible subassembly in a top level assembly, okay, and you are going and changing some things in assembly, it will, as you know, the hierarchy, it also updates all the mates if you are making any changes. So it will take much time to, it will calculate all the mates of that flexible subassembly, and then it will calculate the top level assembly mates, and all these background process take a lot of time, and you face lot of performance issue if you face a lot of time to update, save, or if you are editing something, it takes a lot of time to update. So these are small reasons that it takes a lot of time. So these small things you have to keep in mind if you are working in a large assembly. Second thing, last thing, avoid mating to pattern instances. Okay, pattern instances and assembly geometry. Okay, so in an assembly, you have a lot of linear patterns, circular patterns you are using. You have mirrored components. Okay, you have different assembly features. Try not to make to those particular faces to the faces of pattern instances. Not to make to any of assembly feature you have introduced. Okay, try to make it to the component faces, parent faces, so that it will improve your update time. Okay, so we'll easily move to our next slide, which indicates some of the settings that you have to do in your assembly to improve update time. Suspend automatic rebuild option allows you to make multiple changes and then update at once. So you are doing a lot of changes. Okay, you do one change, you again update the assembly. It will take a lot of time. You do 3 or 4 changes and you update. So why can't you do all the changes in one time and then update the assembly? So what exactly this option used to do? It used to automatically rebuild for each and every change you do. You have to uncheck this option so that you can update assembly at once after all the changes has done. Okay, do not rebuild when switching to assembly window. This option will let you skip the rebuilding of large assemblies after editing a component in separate window. Okay. If you are basically what we do, we right click in any of the component and we'll open it. We'll do some changes, and again if you are switching the window, no, there is update happen and it takes some time to update the assembly. So it is because you have check that option. So there is option in assembly. Okay, so you have to uncheck that option that uh, if you are switching a screen in assembly, it will not rebuild. You have to do it manually. Okay, you can switch your windows very easily. So this option is very much important if you are working in large assembly. If you are trying and opening any component, you are doing changes, lot of changes you do. Okay, so that time you have to make sure that this option is unchecked. Okay, so and third option is disable verification or rebuild. This option lets you to suspend the advanced body checking verification. So these three settings you have to make sure that it is unchecked in while working with large assemblies. Okay, and in SOLIDWORKS 2019, one option is introduced. It says lock rotation of new concentric made to toolbox component. If you are having a lot of toolbox component, earlier you have to manually log each and every you have to manually log each and every of that particular toolbox component. So in SolidWorks 29 you can directly right click the toolbox folder and you have to automatically log the rotation of each and every concentric made of related to toolbox component. Okay, to further reduce the graphic demand of your assembly. Okay, so what happens, you do lot of changes in assembly. You have to zoom in, you have to rotate your assembly, you have to go to particular area, one area to different area of an assembly. So you have seen there is some of lag while doing all these things. So in order to improve that, there are some settings you have to take under consideration in option. I have shown all those settings in my PPT. You can note it down. Okay. Moving further, last thing you can see, there is a fantastic option SolidWorks has provided you to find the bottleneck in an assembly. Which particular component, which particular part in your assembly is having issue or having which leads to a lot of which is demanding lot of performance, which is demanding lot of resources of your computer. So that can be found out with this performance evaluation tool. By clicking that, there are some things it is indicating. Okay, first it shows open time of each and every component. Okay, so here you can see that fixed plate is taking more time compared to other components, 0.28 seconds. Second, it shows the files of all the files for all the components of assembly have been updated to the latest version. It will show that all the files are latest. If it is not, it will give the names of that particular component that are not updated to latest version. So it will give that to you. Second thing, it will give the display performance. So as I discussed about graphic triangles earlier, and also discuss that fasteners basically are having lot of graphic triangles, right? So you can easily see which component is having graphic triangle, large graphic triangles. You can directly go and open from here. Okay, switch the window. So this particular fastener is having more graphic triangles. Okay, and in performance evaluation you can see there are 9 quantities which are adding the graphic triangles to an assembly. So we'll just go and have a simplified configuration of that particular component, and you have to introduce in the assembly, and you can decrease the graphic triangles by that. Second thing, it shows the image quality of the component. It is very much recommended to improve performance that image quality should be low. Okay, so these are all the components which shows that high image quality. So here you can directly open it from here. So this particular part is having high image quality. You can directly go and change the image quality to low. Okay, yeah, by keeping it low, it will show this particular geometry, but it is okay, you know your geometry. If it is highly demanded, you can directly go and change it for time being, but recommended to have low image quality in a top level assembly. Okay, in top assembly it is recommended that the image quality of each and every component should be low, right, in order to increase the performance. Okay, I will easily close it. Okay, so basically, and again at last they gives the details of an assembly, how much part, how much there are unique components, how much number of bodies, how much sub-assemblies which are there in your assembly, unique sub-assemblies. Okay, these all documents. So this particular tool is very much important. You have to check every time with this performance evaluation. If you are minimizing, if you are working with large assembly, you have to check every time. You have to see all the settings are fulfilling or not. So very much informative tool SolidWorks has provided for basically for large assemblies. Okay, we'll move forward. Okay, we have completed best practices for assembly to improve update time. Okay, to improve the update time of an assembly, we'll move forward and we'll see best practices to improve drawing update time. Yes, so basically working with drawing with large assembly is very much hectic, very much tedious process. There are a lot of performance issues. There are a lot of zoom in, zoom out issues which slow down your performance, and also it further it hampers the production time. You release your drawing very late. So this all these things you have to there are some best practices that will release some of your hectic processes which you do with drawing. Okay, first point says that use HLR drawing view. Okay, there are different types of drawing view in SolidWorks drawing. It is very much recommended that you have to avoid HLV or wireframe drawing views. These views are more expensive to drawing than HLR drawing views. Okay, and HLR drawing views have fewer edges to draw, so they generate and update faster. Okay, second thing, it is use simplified version of a model. Okay, as I discussed earlier, there should be simplified version of a model, right? And so that it will also decrease the number of edges, decrease the number of lines in drawing view. Again, it will lead to improve the performance. Limit section views. Section views are dependent view. Okay, dependent on a different view. Those are much complicated views. I know it is very much required to have section view of that particular area. We'll limit it to some extent. We can try and avoid use of section view in some of the cases. Okay. Okay. You have also in drawing you have to turn off some of the options. I will show you in I'm opening one assembly. Okay. Settings, drawing settings. In that performance, you have to uncheck these three options in order to improve update time of a drawing. Show contents with while dragging drawing views, allow auto update when opening drawing, save tessellation data. These settings should be unchecked if you are working with drawing. Okay, so this will improve your update time. Next, again you have to use performance evaluation tool to find the bottleneck in drawing. You have to be strategic. If you are making 30 changes in your drawing views need to recalculate and redraw. For efficiency, it is better to make multiple changes and then update the drawing views only once. High quality drawing views typically take more time to create and rebuild, but less time to save when compared with draft quality views. So try to use draft quality views. Okay. Again, if you have to export the PDF, you can easily go and change it to high quality views. If you are working, if you for time being, you can keep it as draft quality. So there are some you can be strategic. You can use your strategy to improve your drawings. Okay, improve assembly update time. Again, we discuss how to improve assembly update time. Follow all those things with assembly. Automatically, it will release the drawing performance. And since 2020, one fantastic we can say mode is introduced in drawing in 2020. Okay, detailing mode. What exactly detailing mode is? It allows the to open drawing without loading its reference documents. So I will show you what exactly it is. Close this drawing. Okay. So I have one. So if you are going to open an drawing, you can see that there is a detailing mode with lightweight and resolved mode. There is detailing mode. I will quickly select that detailing mode. I will open the drawing. So you can see this assembly is having more than 5,000 components. Okay. If you are going and opening this assembly, this drawing in resolved mode, it will take 5 to 6 minutes to open, but in detailing mode very easily it get open. Okay, you can see all the bill of material. Okay, you can go and give the dimensions to particular area very easily. There are multiple sheets, there are different sheets in drawing. You can easily do all the changes. can add some dimensions. You can do ballooning of particular area. So all the things you can do which you do in drawing in this detailing mode, but very easily you can toggle to different shades. So this is detailing mode which is introduced in 2020. Points that you have to take under consideration while working with large assembly drawing. Okay, we'll again move to next slide, which says hardware consideration. Okay, it's a very key thing. All these best practices you have to do perform on recommended hardware, which is with reference with SOLIDWORKS minimum hardware required for SOLIDWORKS 2019 or 2020. So on website you can find the link, or I will provide you that link to see if your hardware is as per the SOLIDWORKS 2019 requirements. So considering RAM, make sure that you have enough physical RAM to avoid paging. Okay, when you exceed the physical RAM, your operating system borrows space on your local disk drive to supplement the RAM. So this particular process is very much tedious. So it is very much economic also to increase the RAM. Minimum 16 GB is required for SOLIDWORKS 2019. Considering CPU, faster CPU is always better, and the clock speed of the CPU should be 3.3 GHz or more. Okay, faster processors are helpful for most, but not for all the operations. So again, opening and closing time of a file can be increased with the help of SSDs. You can introduce SSDs in your hardware system, which is very much faster to update, to open drawing. Okay, video card means graphic card must be of NVIDIA Quadro platform. NVIDIA GeForce is I have seen with many of the companies that they are having gaming graphic card which is NVIDIA GeForce. You have to be on NVIDIA Quadro platform. Any memory means 2 GB, 4 GB is sufficient according to your working. NVIDIA Quadro platform is supported for SOLIDWORKS or any CAD platform. Okay, so these are all hardware consideration. You have to make sure all the hardwares, all the things are as per the SOLIDWORKS 2019 recommended hardwares. Okay, so with this we complete all the best practices. We have discussed all about the hardware. We seen opening time of an assembly, how to improve opening time. We have seen how to improve update time. We see how to improve the update time for drawing, and also discuss the fantastic tool which is introduced in 2020 detailing mode. Okay. By this I conclude my webinar. Hope all the best practices I discussed will help to increase your large assembly performance